Our first speaker of the evening is György. If you've participated in some of the meetups already in the past, or I mean Budapest.js meetups, or just checked out our YouTube channel, you already saw György in action. He's a frequent presenter of the meetup. I'm very happy to have him here yet again because he has a very special, I would say, special attitude and approach to doing presentations, which are really funny and still very informative. What you need to know about György is that he's a cat guy, not a dog guy. I'm sure he doesn't hate dogs, but he has a cat. And he's very much into computers and computer science. So he's always going into in-depth topics. You saw the cat as well. Thanks, Gyuri. So today we will go a bit more in-depth into database stuff. And I hope you guys will learn something new, because I'm sure you will learn something new. I already had a sneak peek of the whole thing. So Gyuri, the stage is yours. Thanks again for doing this talk.
All right, thanks for the introduction, Norby. Let me just share my screen, because then you can actually see the presentation. Oh. Okay. Right, this is easier live, trust me on that. Okay, everything is visible, hopefully. Someone let me know. Okay, seems it is, right. So, my name is Kovács György. I'm tech lead at GoodGrind. And that's the introduction I'm going to give you today. That's all. But what I want to talk about today is Knext.js. And before I mention anything about the library itself, let me give you some context on the project we used it on, which is named TPM, short for TV Process Manager. Not a very imaginative title, but a very appropriate one. The idea here is that our client, which is an advertising agency group of some description, wants to use it to digitalize all of their TV advertising related processes. So everything we can do automatically, we should. That's the broad concept. Now, one interesting aspect to it, which was also surprising to me, is the granularity of data that they're working with when it comes to reporting. So, for example, they know that, for example, let's say 0.3% of all women aged between 18 and 49 who also have a dog but not a cat that were watching the advertisement running on channel Awesome at 11:53 a.m. or something like that. That's one end of the scale. And on the other end of the scale, we have yearly reports that aggregate all of this data to figure out whether a specific advertising campaign over or underperformed. Now, if we just to go with some ballpark estimates, that means we need to track 100 channels, each running 500 spots a day. And then this is broken down into 200 target audiences that we care about. And for reporting purposes, we need to retain 2 years worth of data. So if you combine all of this together, we end up with roughly 7.3 billion ratings that we need to consider. Now, if we just use 1 byte to store every single piece of data here, that's already 7.3 gigabytes. That's a lot of gigabytes, or, well, a fair amount anyway. So with the scale of data, we had some interesting challenges, and part of the solution there is Knext.js. So what even is that? Let me just give you a brief introduction there. It's, well, the title or the tagline goes, it's a batteries included query builder, but the name itself should be a clue. It connects you to your database. That's the idea. It's super simple. You just use it and then you can query stuff from the database. That's it, nothing more. So database independence is one feature it has. So you are free to care about the database specific issues, and it makes your life easier when it comes to building SQL queries. And it also has a whole bunch of other bits and shits we're not really going to talk about here, but they round up the whole package nicely. So what does this look like in practice? On the left-hand side, you have here a SQL query. It's fairly standard. We select a single column from a single table and do some filtering as well. In Knext, this would look something like this. Now, you might think that the only thing I've done here is just add a bunch of parentheses and apostrophes around everything, and otherwise, what is really the point? But there is a subtle but important shift that happens between the two. On the SQL command text level, we're dealing with the textual representation of the query. On the next level, we are actually dealing with a abstracted logical representation of it, kind of like, think of it like the source text and the abstract syntax tree. Now you care about what pieces you put together to form the query and not necessarily what kind of specific characters have to follow one another. If this seems a bit too abstract so far, it will make sense eventually, trust me. But suffice to say, this is one thing that gives Knext the ability to be database independent, since you no longer care about how the query itself is represented in the database level. You can just put it together from sort of more abstract building blocks. Like this goes in the select. This is what I want to filter for. So why did we end up choosing this library for this specific project? Why not just go with well, the first obvious choice would be just SQL text. That's the very low level command interface that we have for the database. We could have done that. Well, that obviously has security and correctness issues when you're just using string manipulation to put together your commands that you execute against the database. Little Bobby tables, you know that story. That's not a fun place to be in. But even aside from that, if it's not texture manipulating, but higher level function calls, methods, then it becomes easier to reach to your usual tools for code reuse and function decomposition. So if you have a reusable SQL snippet, then you can just put that into a function, add parameters to it, and so on. You can do the same thing in the database level as well with views, stored procedures, which is a bit more cumbersome. Sometimes it is necessary and unavoidable, but certainly this is a more flexible and comfortable option for at least those of us working with JavaScript and whatnot. So the not transact SQL or whatever, PL SQL or whatever they call their database specific programming languages that you have for every different database vendor, because of course they have to be different. Okay, so that's one advantage of a query builder. Now, why not go with an ORM solution? Well, the thing there is then we would be able to, like SQLize, for example, we would be able to just throw entities at the database and they are magically persisted, and you don't care or don't even know how that happens as far as the SQL is concerned. And in our case, that's exactly the problem. That with this level of data, you do deeply genuinely care what exactly is happening at the database level. Because if you don't, you're going to be missing an index, you're going to have the query optimizer fall on its face, and suddenly your performance goes to shit. So to avoid these problems, we need full control over what happens at the database. And with a query builder, you get that. Now, the third alternative, and I swear I did not know Prisma.io was going to be a sponsor before I put this up on the slide. Why not use Prisma.io? Well, the reason is simple. At the point where we started this project, it did not support Microsoft SQL Server. That is what we use in production, so it's out of the question right off the bat. But aside from that, it still has a bit of a difference when or Knext still has somewhat of an advantage. And that is when it comes to raw queries. Now, the idea of raw queries might seem a bit strange, like why are you using a query builder if you want to run text as SQL queries anyway. And the reason is that however general your API is, it will not be able to cover absolutely every feature, every database out there, and that is fine. So sometimes you need an escape hatch like this. The difference is that with Prisma, as far as I know, maybe this has also changed since then, this is an all or nothing type deal. Either you use their API and just use nice object and relational based query creation, or you just pass in a string and then that gets executed. With Knext, it is all the way through a query builder, so you are not escaping from the query structure itself. That means it's even there when you're writing role queries. So you can just take one of those tiny little building blocks, which would go into the select clause or a join condition or a where filter or whatever, and then replace just that tiny little part with raw SQL. So this modularity gives you a lot more usability. You don't have to pick and choose between one or the other option. You can more easily migrate from one to the other. All right, so that is why we pick Knext. Now, I would like to talk about some of the different things we did on this project, which might not be so obvious. This is not something you're going to see in the getting started documentation or in tutorials or whatnot. That doesn't mean they're super complicated or anything, but nonetheless, seems to be okay. This seems to be somewhat possibly intriguing. So maybe for your use case, it's not really worth your time, but nonetheless, these are some ideas to consider. So one thing is that Knext by default has a primarily string-based API. So every parameter you can think of, if it's column reference, it's going to be a string. If it's a table reference, that's also a string. If it's a string value, that's also a string. So, okay, there's a number here on this slide. That should have been a string too. But either way, primarily everything is just expressed as a string, expressed as a string, which is fine. It's super easy to use. However, this is anything but type safe as a result. So Prisma.io already had a decent idea for that. You look at the database schema, generate a bunch of constants from that, and there you go, you use those instead. We can do that even with whatever tool Knext provides fairly easily. So in this case, you no longer have the option or even the choice of accidentally introducing a typo to a column reference and then having your queries break in the most inopportune times. Furthermore, this gives you a confidence when you're doing refactoring at the database level. You can just rename columns or even drop them. Once these generated constants are refreshed, you will notice that the compiler is suddenly complaining about a missing property. And as you might expect, you also get autocomplete in this case. So effectively, this gives you strong typing based on the database schema. Now, this is all fine and dandy if you're including every table just once in your query, but sometimes you need to join the same table twice. The way you do that in SQL is you give an alias to that specific instance of table so you can reference it that way. Now, this is something we could do for you with pre-generated constants. So in this case, you generate your own. You have the schema for a table, give it a name, and store it in a variable. Afterwards, you can just reference this variable like you would any other table, or just similar to the built-in constants. Third addition or extra that we were using is the utility functions for row queries. So one thing to know that yes, we did need to use row queries in the project in a couple of places. That doesn't mean you have to do so like a savage just with string concatenation. There are civilized ways to do this. So let's look at what row syntax looks like in Knext to begin with. It's not necessarily the friendliest. There are always two parts to row query. First is the SQL command text, where you can or where you have to replace the bindings with placeholders, and then an array of bindings, which are the actual values that get put into the SQL. So Okay, it functionally it has everything it needs, but this is anything but user-friendly. Thankfully, JavaScript has a neat little function named tagged template expressions. Now, a template expression is something you've probably already seen. It's a string with those weird little backtick quotes and whatnot, and you can put expressions inside of them. And at the end of the day, all of the things that are in there get converted to a string and concatenated, and that's your final output. So that's an easy way of mixing just plain text and various expressions. Now, that's kind of what we want to do here as well, just output a different format. And JavaScript gives you a tool for that, which is tag template literals or tag template expressions. The only thing you have to do is add the tag, which is actually a function, before the template literal, and then instead of the concatenation logic, you can do whatever you want with these pieces of text and the expressions. So in this example, the second line just produces the exact expression you see above it. That's it. Now we can add additional utility functions built on top of this for specific use cases, such as function calls. Well, it's primarily just a function name and a list of arguments. So if you can specify that, you're already good. And thanks to the magic of function binding, you can easily create your own function wrapper for just the specific function. So you don't have to specify the function name every single time. Now, a third and final example here is raw template literals, which again, the usual syntax is kind of awkward. The purpose of this is to define a value that is definitely going to be a string. It's not ever possible for this to be a column reference or whatever based on the context. This is always going to be just a string literal. And I think that's pretty much the only valid usage that you see in reasonable code. But well, this is very cumbersome syntax for something super simple. So we just add the wrapper for it. So you only specify the string you want to convert, and then there you go. So now, on a bit of a different track, this is not really an addition to Knext, but how we organize the code is somewhat different than you might expect. So you might see in a lot of getting started guides and whatnot that the builder syntax just follows the exact structure of the SQL query you're going to build. So the select statement is at the top, then you have a from and a join to take the data from two tables related in a certain way, and then add some filtering on both of them. Now, the thing is that with a query builder, you're creating a query from logical building blocks anyway. So while you can do it this way, you don't have to. And since many of these operators are context independent or even order independent in some cases, you have considerable freedom in rearranging them. So if you take this same query and just reorder a bunch of stuff into the way the actual processing pipeline would work, you get something like this. First, you define your first source table, then the filtering on it, and then some transformation on its output. Then after all of that, you join in the second table. Again, define the filtering on that table and the output transformation for that table. Now, the useful thing here is that now the related code that is dealing with data from the same table or tables is located next to each other. That also means that you can just take this part. Hopefully, it's not just a coincidence that they're together, but it also represents some kind of business use case or like some small version of business requirement, in this case, including the address for each person. And then you can just shuffle this out to a function. And thanks to Knext being awesome, you can even use this inline. So this way, you have managed to introduce higher level, hopefully business relevant building blocks into your query builders, but you still have all the power that you did before, just on a higher abstraction level. So that's as far as query construction goes. Now, the other major tool we built is, well, dealing with the database schema directly. This is kind of similar to, I don't even remember what it's called in Prisma, actually. Not the client, but kind of the same thing. So the first step in getting useful data out of the database schema is extracting the schema somehow. Thankfully, there are system tables in most every database, certainly a SQL server, which lets you run SQL queries against them to actually get the metadata from the database. So that way you can extract the list of tables, columns, indexes, foreign keys, primary keys, pretty much anything you could ever want to know about the database. And if you've done all that, you can package that together into a reasonably human-friendly, but more importantly, computer-comparable JSON file. And then you have a snapshot of the database schema. Then one thing you can do with it, and one thing that we actually do with this, is schema validation. Now, to understand what this refers to, first I need to explain a bit about how Knext handles different database version upgrades. The migration process there involves a bunch of steps where you can define basically an arbitrary piece of code which will take your database from the current version to the next and hopefully keep all of your data. And then you can define a different piece of code that does the same thing in reverse. And there you go, that's a migration. You have an up step and a down step. Now, the problem with this is that you're always defining deltas and you're writing code, so therefore it's prone to having bugs. But the thing you care about is actually the end result of running said migrations. And that is where the schema snapshot comes in. Once you've done your migration, you can take a snapshot of the actual state of the database, compare that to an expected state you have checked into Git. And there you go. If the two are the same, everything went fine. If not, you probably screwed up somewhere. So the third and probably most interesting aspect of this tool is code generation. So now we have the schema as a friendly JSON that we can iterate over. It's pretty easy to generate basically anything you could want out of it. Now, the things we do generate, well, let's start with reference helpers. You've already seen those. These are the pre-generated constants for accessing different columns. Now, you might expect these to just be of the form table.column as a string, but the reality is a bit more complicated than that. We actually wrap everything in knext.ref objects, and the reason for that has to do with a minor quirk of the Knext API. So, as you might have noticed, everything is strings, so that means sometimes you need to be able to choose whether that string means a column reference or whether it is a literal string value. And that also depends on the context and position of the arguments. Let's take this where clause, for example. The first part references a column, and the second part is a value that it gets compared to. So far, so good. Now, if we also take a look at a join call, the first argument is going to be the table we're joining, so ignore that. But the second one is going to always reference the column, and the third one is also going to reference a column. So far, so good. However, as far as SQL is concerned, it's also entirely valid to do it the other way, where both sides of a where clause reference a column, or a join condition happens to join a column and a constant value. So you might try to naively do something like this, change the value to something that looks like a column, or change the column that's something that looks like a value, but unfortunately, this won't work. As far as Knext is concerned, they're just strings, so it has absolutely no way of telling them apart. So what you do need to do in this case is have a wrapper object, which can then be recognized at least. For columns, this is going to be a knext.ref, and for literals, this is going to be a knext.raw wrapper object. So, long story short, this is why we generate reference objects instead of strings, so you don't have to care about this at all. You're just free to use them in whatever position you want. Now, the next thing we generate is ID types. And again, I have to take a detour, this time into the lens of structural typing. So TypeScript by default uses structural typing, which, as you might guess from the name, looks at the contents or structure of a type to determine if it's compatible with another type. This is opposed to nominal typing, found in quite a bit of other languages, where you only check the name of the type to see if they are compatible. So in TypeScript, the following code is entirely legal. Let's suppose you have an interface, you're dealing with animals which have a name and a weight, and your code is also concerned with household appliances which also have a name and a weight, but the two are otherwise unrelated. So you can create an object of one kind and one of the other, and it's perfectly valid to assign one to the other. So now your cat is a toaster, which may or may not be what you want. Now, with nominal typing, this assignment would be impossible, or rather compile time error. And in TypeScript, you have to do a bit of legwork to actually get this to work. The way you do that is this. Now look at the magic. The right side is a bit cryptic, but all it says is this has the same properties as the original base type, which is represented by T in this case, and it also has a type name field, which is some kind of string. So after you have this, you can declare your types as nominal by declaring the base type and some unique identifier. You can use this then to create values of these types. You have to add the cast there to actually allow this. Note that this cast is not a forced cast in the sense that it will only accept values that actually belong to the base type. So this will work for numbers, but not for strings, which is exactly what we want. And then the following assignment will throw a compile time error saying that the type name properties are incompatible, which is exactly what you want. So, as you might guess from the title, this comes in handy for database IDs, where pretty much every ID in your database is just going to be a number, but regardless, you don't want to pass a person ID where you expect an address ID. So that saves you from some class of errors, which is always nice. Third thing we generate is interfaces for the database records themselves. By that I mean the rows in a specific table. So if we have a table, it has a bunch of columns with different types. Then we generate a corresponding JavaScript interface where the ID or the primary key will become an ID type. The types in the database are transformed to their JavaScript equivalents, and the property names are converted from snake case to camel case. Simple as that. Now, we do a bunch of straightforward type mapping, but also some custom conversions in some cases, which you can see with the ID type. So not every integer is obviously going to be converted to an ID type, just certain ones. And going further than this, you could even write or even generate the conversion code for taking the raw objects that Knext returns and converting them to, well, whatever interface you happen to be generating here. That's useful, for example, for the types, the database types, which do not have a straightforward JavaScript equivalent. For example, in the database, you have dates, times, date time offsets, where in the JavaScript side, by default, you only have a single date type. Now, if you want to use custom types to represent all of these on the JavaScript side as well, which definitely has its uses, then that is the kind of conversion logic you could add here. In our case, we never actually implemented this. We just use a global generic converter stuff, which handles 90% of the cases and then do the rest manually. Now, another cool addition that you can have here based on the schema is relationship traversal. So if you're going to do a join from two table or from one table to another, as far as SQL is concerned, you can join on any column and any condition. but the vast majority of the time you're going to be navigating using a foreign key from one entity to another. And if you inspect the schema, you will have the list of foreign keys there, and you can also look at the unique constraints on various tables to figure out whether said relation is a one-to-one or a one-to-many relationship, and then just generate a bunch of helper code based on that, so you can navigate directly from a table using the name of a relationship to another table, and then that will add the joins to your query as needed. Now, the code for this looks something like this. In our case, it was never actually implemented, but it's a cool idea nonetheless. Maybe we'll get around to it sometime. So that's a very brief tour of the features and stuff that we did with Knext in our project. And I also have a couple of ideas about these ideas. First is that code generation is actually a surprisingly powerful and useful tool in some cases. So if you don't want to touch the resulting generated code at all manually, and it's going to be static after it's generated, then yeah, you should maybe consider making more use of it. It's not exactly panacea, so it will not solve all your problems, but the amount of effort you need to do some fairly useful stuff, well, it can be worth it in some cases. So definitely add this to your toolbox, I would say. Now, the other thought I had is, have we just built an ORM ourselves from the ground up? Like, what was the point of that? And I would argue, no, not really. Because every abstraction presented so far here is fairly straightforward, simple, and more importantly, granular. So it's just tiny building blocks put on top of one another. If you happen to need something slightly different than what is there in a utility function, you can just take those 4 or 5 lines that make up that utility function and modify it to your heart's liking. You still have the full control over what happens at every step of the way. This is in contrast to an ORM, where if you want to do something that's not the default behavior, you're gonna have a bad time. Third is that now we have managed to create a whole bunch of tools whereby you can easily express fairly complex queries. The problem with that is that people make use of this power and actually do create rather complex queries. But just because you can doesn't mean you should. So I've pulled out a real-life query from our real running application. Actually, I just searched for what is the slowest query that we have, and this one is it. Yeah, so if you're getting to this point, it's time to stop. Because if you ever want to debug or maintain or optimize this query, you have your work cut out for you. So that's something to still keep in mind. To close it off, here's a bunch of puns I chose not to use for this presentation because it was getting pretty annoying already. And that's enough for silliness. Time for some super serious questions. If you have any.
Thanks, György, for the talk. We actually do have questions, and you can still write those questions in the comment section on YouTube. While you do that, I'll start with a question from my side. In hindsight, do you think, would you still start with, I'm going to go now down the path of heresy on a JavaScript meetup with JavaScript, or would you pick something else in general?
Well, I don't think this is, I'm not sure if this is actually related to the talk or Knext.js specifically, but here the difficulty had nothing to do with JavaScript specifically. Like, yes, it's a dynamic language, but we use TypeScript anyway. We generate strongly typed stuff, which is tied to the database schema anyway. So you could do this in pretty much any language. I think on the Java side, Juke looks something fairly similar to this, and that's not JavaScript. As for whether I would pick JavaScript for the project itself, I don't know.
The reason I asked because I would say in the past the whole ORM and relational database management story of Node.js was pretty sad. So we had SQLize and Knext beta, and more or less the rest of the libraries were still either in an early phase or just one-man shows, kind of. This is why I asked.
Well, the only comparison I have is the entity framework from quite a few years ago when I worked with it in C#. That's the standard Microsoft endorsed ORM there, which does everything wonderfully out of the box. And it was still a fucking pain in the ass to actually get it to produce fast queries on an insane data set. So we ran into the same problem here. I think it's kind of a conceptual problem with ORMs in general, that you can't really have the same level of control as you do with a query builder. Now that you don't even have the choice of a decent ORM on Node.js, that might be another sad story. But Prisma.io is here, so maybe that will solve our problems. Hopefully.
Yeah, hopefully, I'm hopeful for it as well. We have a question on the YouTube chat side. Can we bring that up somehow here? I think last time. Awesome. Judge, you can read that, right?
Yes.
Performance-wise, how this is performing.
The question is not even wrong, is how I would go. But it is a good question. This is a query builder. This lets you take an object structure and it spits out a SQL query. You can just create whatever query you want with it. The question is whether that query will end up performing properly in the database, and that's something you need to answer elsewhere. So if you have the proper indexes in place, the proper data structures, then yes, you can achieve as much performance as you would with just plain SQL queries, just writing the text yourself. So this is not going to be the bottleneck of any kind.
So we can say that in this situation, it's up to you, the developer, while if you're using, let's say, an ORM, like you mentioned, entity manager, that tries to do some magic behind the scene, and it will either help you or make your life miserable.
Yeah, exactly. So there is no magic between you and the database. You can fuck up your performance exactly how you want, or it can be as awesome as you can make it.
We also have another question from Christian. What do you think of standard JS? Hi, Christian, by the way.
Yes. Old colleagues. So I don't really have an opinion on that. I don't even know off the top of my head what it precisely is. I think it's just a collection of linter rules in the end. Or maybe I'm mistaken and that's not what it is, because the name is not very descriptive. But
yeah,
fine.
it should be just linter and formatting and whatever. So a bunch of.
I mean, I think linting is useful, but again, that's not really where the most problems come from, in my opinion. If you just pick one standard, whatever it is, it can be a standard rule set for TS-lint, ES-lint, JS-lint, whatever. It doesn't really matter. Just pick one and go with it. There you go.
Okay, any more questions from the audience? 3.
You can also ask about SQL performance issues if you want. I have another presentation on that, but that has nothing to do with JavaScript. So
okay, if you're interested about that topic, drop a note in the chat, so Judy will know to create a talk about that one as well.
Yeah, you can see my email there in very small letters, but there it is.
Yes. And also, if you have any more questions at the end of the whole session, you can still ask Judy. For now, thank you, Judy, again for doing the talk.